Hey everybody, this is Larry. This is the 17th of June on the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And it is loading. Number of subarrays with bounded maximums. So usually I solve these live, so if it's a little bit slow, just hang out for a little bit or watch it on 2x. The technology exists. Anyway, we're given an array nums of and a positive 2 and 3. We turn the number of contiguous subarrays such that the value of the maximum array element that subarray is at least left and at most right. Okay. I mean, this is the length of nums. Okay, and is the value of the maximum array element. Okay. Let's see, right? So this is going to be some sort of, at least my guess is some sort of 2 pointers or sliding window, if you will. So what happens, right, is that when you slide, the number of subarrays, well, there's only two situations. One is the condition is being met, and then the condition is not being met. And if the condition is being met, then it's just, the number of subarrays is just the window that we're given. And if it's not being met, then we have to keep on adding numbers until it is being met. Yeah, and then we have to figure it out and once it goes. So there are only two conditions, right, where it's not being met. I guess there's three conditions altogether. One is that the maximum number of the subarray is less than left. I don't know why they call it left and right. They should just call it min and max or something. I don't know. Maybe that's confusing though. But in any case, yeah, if the max is less than min, then we keep on greedily keep adding. If it's within that bound, we just keep on slowly sliding from the last point of possibility. And then otherwise, if it goes over right, then we have to start over. So I think that's basically the idea. Yeah, because once we pass right, then there's no possible subarrays that includes this number, right? For example, if the max is 3, 4 cannot be in it no matter what. So it splits the array into these chunks. And then within those chunks, you just have to figure out how many subarrays have at least the minimum element, right? Okay, so let's think about it. How do we get? Let's say we always split up the array, right? Then we just do a solve on the number of and then they become independent problems. And for each independent problem, then it should be sliding window, right? Yeah, you start 0, you slide. It's good. Then that means that everything before and after is good. So you can even do some sort of math, right? Because, okay, let's say we already delimited by the maximum number, so we kind of put it into independent problems. So then you basically have, let's go over it for a second. So let's just say we have a bunch of numbers. I'm just going to call it, trying to visualize it a little bit better. But let's just say we have three types of number, right? A is equal to just smaller than left. B is between left and right, inclusive. Yeah, and C is larger than right? So now you have like some string of things. That's way too long for something like that, right? And essentially, what you're doing is you're delimiting by the C. So now you have a problems of just A's and B's, right? Because no subarray will cross boundary for as definition. So now you have just something like that, say, maybe even A's in the middle. And then the problem becomes almost like a reverse, like so you can do some sliding window math to get the number count for sure. But another inverse way of thinking about it is now that you're given this, the array must contain at least this chunk. So that means that the only not possible arrays are the prefixes and the suffixes, right? So that means in this case, you have these 3. That means that the possible arrays are just like 6 or something, right? Because 3 times 2, 3 choose 2. Is 3 choose 2 6? I don't know anymore. Something like that, right? And then the suffix also have some, let's just say a little bit longer. 6 choose 2, right? Because that just is the number of, is it 3 choose 2? Yeah, it should be, right? It's 3 plus 2 plus 1. So yeah. Anyway, we could do the math. Maybe it's not 3 choose 2. But in this case, the 3 strings that are not possible, well, maybe more. Because you have from 0 index, you have 0 0, you have 0 1, you have 0 2, you have 1 1, you have 1 2, and then 2 2, right? So is that 3 choose 2? I'm getting my notation incorrect, maybe, because that doesn't sound like 3 choose 2, but it's actually n times n plus 1 over 2, right? Oops. Right. So yeah. So I'm a little bit wrong in this one. So it should be, but you get the idea, right? That's just the number of possible substrings or subarray inside here. So then now we can take the total number of subarrays, which is again n times n plus 1 over 2, minus this and the suffix. So I think that's the idea. So you can actually do this with a lot of just straight math and intuition. And I hope that I'm right, because otherwise I'm just explaining a lot of things that are wrong. But you know what you signed up for. That's the risk. I'm solving it live. I'm sorry if I'm wrong. If I'm right, I'm still, you do what you can. So okay, let's do that then. So yeah, so I'm going to abuse group by. Should I definitely could abuse group by, but let's not actually. So then now we just have a count sub, maybe, I don't know, of left right. Let's just say index 1, index 2. I usually go left right for my indexes, but this is very awkward. All right, let me just relabel this. If you're watching at home, note that I did relabel those, so watch out. So then now we count is equal to the number of things. So, and this is inclusive, so that means that it is let's just say n in this case is equal to right minus left plus 1, because it's inclusive, and then count is equal to n times n plus 1 over 2, and then now we're looking for the prefix and the suffix. So yeah, left prefix is equal to let's just say 0, and then we do a while loop while left is less than or equal to let's just do if they're equal, yeah, if num sub left is greater than max, then we break. Otherwise we no, whoops. If this is smaller than min, then we continue. So if this is greater than we break, right? Otherwise left plus plus. Yeah, left. No, this is whoopsie. something like this maybe. And this will give us the number of digits that this is true for. And then count, we subtract from left prefix times left prefix plus 1 over 2. Maybe we should put this in a function, but should be fine. For now, let's at least get it right before we do right suffix. Oops. So right suffix equals 0. So let's just say right is still greater than left. Well, I guess if count, what happens if this goes over right? Then this is equal to n. So yeah, okay. So if count is, should we just return 0? Otherwise, we do the suffix as well because that means that we don't duplicate. So yeah, with nums, oops. So this is given a contiguous part that is good, right? So, wish there were more. I mean, we could set up our own test cases. It's not that big of a deal, but yeah. Okay. So then now we just have to divide it. So we go previous is equal to 0, maybe for index in range sub n. I know that the 2 ends, but that's okay. So if num sub index is greater than max, then we have to start splitting it to the left and the right. So then we go, okay, let's also have a total is equal to 0. We add this to the count sub from the previous to index -1. That's also just for 6. If left is greater than right, return 0. Because wait, I guess this is not true if this is equal. If it's equal, we might have to do it loop once because it may have 1 array. 1 element. Previous is equal to index plus 1. Yeah, I think this is roughly right. If the last number is not greater than max, then we have to do it. Maybe I should have just used goodbye, to be honest. Maybe that's fine. But in any case, if the last number is less than max, then we have to trigger it 1 more time. So yeah. So this is a little bit yucky. N -1. Okay. Let's kind of see how it goes a little bit. I mean, the implementation might not be right, but we'll see. Because I think the idea is right. But everyone here knows that my implementation's been kind of bad lately. 50,000, so it should not overflow. That's the other worry. 78. Okay. Let's just try this, but add a couple of. I was going to say 6, but. Alright, let's see. And of course, we do have the cheating ability of looking at the expected answer, so we are more confident than we would be than in a contest, for example. For a contest, I might split it up a little bit more, or write a way of verifying this. This n is very small, so you can actually write an n square. You know, you could check every possible n, or maybe n cube even, just to kind of verify your answer. So for small cases, so that you know. But now I don't even have to. But if I was in a contest and I'm still feeling as unconfident as I am now, that's maybe what I would do. Yeah, let's just add a couple more. But it seems like this is Okay, let's do one where where it's cut off in the beginning or the end, I guess. Yep. Okay, so let's just give it a submit. Hopefully this is right. Oof. Yikes. Why is this wrong? So maybe, like I said, maybe I'm off by one somewhere. I thought I tested a lot of cases though, so that's a little bit sad. Because I quote a lot of HG stuff, but well, okay, let's see. I'll put 23, but it should be 22. 69. So okay, so one thing that I do for debugging is just try to get another case where I'm wrong, which is slightly easier to read. So let's try this one. What do I get? So I still get the wrong answer, which is good because it eliminates some of the possible reasoning. But it's either that or my logic is wrong. Oh, my logic is missing something. That's right. I thought of... yikes. I'm just really sloppy lately. That's my fault. So the answer is that, okay, given the notation that we had before, we have, let's say now we have an inner thing of behavior. I just got lazy and said that this is n times, whatever. But this is not right, of course, because, and it's very obvious, so I don't know why I'm doing it, because you have like AA, for example, in the middle, where that's not true. So you have to kind of figure those out as well. So then now it becomes delimiting not just by left prefix, but now you're doing a second delimiter, going further away. Yeah, so let's do that. So yeah, so I did it with the left prefix and the right prefix, but you have to do it for the inner side as well. I'm just really sloppy today. Like I had to, okay, I mean I didn't have the right idea, but I mean I had the right approach, but I didn't take it to a logical conclusion because I didn't really think it through. And that sometimes happens when you rush things a little bit, and I definitely maybe rushed things a little bit here. So yeah, so then now we delimited, and this is where maybe using group by would have been very helpful, because it's just easier to write. Okay, but basically what you would do is you would do the same thing here, where you just go left to right and then try to do it. Yeah, basically you're delimiting by the B's and you're trying to find the insides and then subtract them for each independent one. I'm going to just cheat a little bit now and then using group by. What is group by? Basically, group by is a thing in Python that allows you to split essentially an array into. I mean, there are things to go about it, but you basically, you split a thing into things that you can group by, and then you use that in a way. And one of the ways you can do that is, so group by nums, forget the syntax actually, so maybe there's a good upself, iter tools, I think. So I'm just reading up the API real quick. Okay, iterable and then key. Oh yeah, okay. So so key is Leetcode. Is that the name of the, yeah, okay. I was just making sure the name of the parameter name. So basically for an X we just group by whether it is bigger than the max. Sorry friends, I know that this video is a little disjointed. I'm a little bit tired, just too tired today in general. But hopefully this makes, I mean the algorithm makes sense. I just been very sloppy about it. So yeah, so for, what does this return? This is for key and a group in this. Yeah, so if key is false, so if not this, because, so what is the key? Key is, it takes this function and then it groups adjacent elements together by that key. So, and because here we choose the key to be greater than mx, meaning that so now we group together all adjacent elements where it is not the it is smaller than the maximum thing or equal to. So then that's why I chose if not, then we do this thing where let's just do count subarray. I don't know how to call these things. I don't know, my brain is not really working today. My apologies, but we can just pass in this iter tool. Let's make it a list because it is an iterator by default. So let's make it back into a list, and then yeah, we can just define this. Let's return 0 and print it out because just in case I am even sloppier than usual. I have my confidence. I don't know. I've just been doing some playful testing, coding all day, and I don't know. Maybe also I'm a little dehydrated, to be honest. But this looks good, right? For 1 and 5, for this one, like it's intentionally to show, yeah. So everything looks good. So yeah, and then now, like we said, n is equal to the length of arg. Total is equal to n times n plus 1 mod 2, or divided by 2, I don't know why I say mod. And then now I do 4k g again, and now we group by the other thing, which is if it's greater than or equal to, what is our delimiter? Oh yeah, our delimiter should be now bigger than, so now we just want to count all the smaller numbers, so we use this as the delimiter, meaning now we have numbers that are no good, right? So if these are lower numbers, we subtract it by, I don't know, count subarray 2, and I think that should be good. And that's why I remember, I don't know if this group by thing is more readable. That's why I didn't write it this way. But the other code was pretty yucky as well. So yeah. So that's why I didn't like it. Okay, now let's give it a spin. Okay, so everything's good except for this one. Dun dun dun. Why not? Why not? I mean, this one's good. All the other ones are, oh no, this one's not good either. I might have a off by 1 on the eco signs. So we are smaller, we should subtract from it. Let's see. Oh man, I have to convert this into a list. What am I off by? I am now curious. I mean, it's probably just off by 1, but so we add these two. Oh no, we subtract by this. N plus, is this formula wrong? So if it's 1, it should be 1 times 2 times 1. So that's right. So why is that wrong? Dun dun dun. I don't know if this subtract 1 is from the same. No, it should be from the same. Why am I subtracting 1 again? Dun dun dun. Oh, okay, typo. That's the scoping thing is a little bit awkward. I probably should have been better. Okay, now everything's good. So let's remove our debug things. Run it again. And yeah, it looks good. So my algorithm is still mostly right, but my implementation again failed me. Why am I such a bad coder these days? I don't know. Maybe I just need more sleep. It's been a crazy month. Okay. So what is the complexity here, right? Well, for even though this looks very confusing and there are a lot of for loops and stuff like that, each element only gets looked at a constant number of times, right? If each number is bigger than max, it gets only looked at like once or twice, and then here, again, so basically each number only gets looked at like 3 or 4 times. So this is actually, even despite how it looks like, is linear time. In terms of space, you can definitely do this in linear space if you're not silly like me and you're better at bookkeeping, which was my first attempt. The way that I did it, we construct a lot of lists, or not that many actually, because we construct constant number of elements for each list. We put each element constant number of times in a new list. So it's linear time, linear space is what I'm trying to say. As you can see, I'm struggling for some reason. Allergies still kicking me butt. I have a lot of excuses. But no, this is linear time, linear space. So yeah, but if you if you follow through what I tried to do in the beginning, you can get that in O of one time. In O of one space and O of n time, but instead the way that I did is linear time, linear space. But it is much easier to write and much cleaner, and even the debugging only took like a couple of seconds. So yeah, that's all I have for this one. Let me know what you think. It's kind of a long video. It's a little bit sloppy, but the idea is sound. I don't know. Hopefully you get to understand how to attack a problem with my way or something. I don't know. Anyway, I will see you later. Hope y'all have a good rest of the week as the weekend is coming up. And I'll see you later. To good mental health. Bye bye.